Greetings of the day. My name is Rhythm, and today I'm hacking with Ganesh. And this is our submission to Data Hackfest by MLH. Hey, let's meet Ajay. He's a working professional and a product management specialist. He has been continuously applying for job opportunities. After sifting through multiple listings, he still hasn't received any reply from the respective organizations. This fueled as our inspiration for the weekend, and we decided some problem statements, which include applying to jobs today. It has still been following the traditional methods of applying on resume shortlisting websites and receiving a cold reply or even no replies at all. The key problem that candidates face in such scenarios is the lack of tangible understanding of the pitfalls that cause them to be rejected at multiple job listing websites, as there is generally less or no reviews upon their candidature. Secondly, students are often confused about the type of job roles that they are fit for and after graduation or maybe even before. If they could be connected with the right kind of objective data understanding as to the careers pursued by other people at their age with similar profiles, they would be at a much better state of understanding what sort of career options are available to them. So, what did we do in the project? Our project aimed to achieve an objective solution to these two growing problems. First, giving candidates tangible profile scores based on their previous qualifications, achievements, and extracurriculars. Secondly, connecting candidates to the right domain of jobs based on their profile to kickstart their careers. How did we build it? Our solution was built with techniques as data cleaning, feature engineering, and modeling algorithms that can accurately rank candidates by comparing profiles of numerous other candidates. Dataset obtained through Kaggle, coded with Love using Python. We ran through many challenges as well, which include implementing a scalable solution was difficult given the limited resources of our own local systems. The dataset comprises of jobs from all possible domains, ranging from truck drivers to accountants to even developers. So the recommendations are based on a weighted average across categories. What are the accomplishments of our project? We made the analysis to understand how the job market has evolved through stages in different domains. Secondly, we implemented models for both problems with accurate enough results, based on testing with our very own profiles. What did we learn in this project? We used ML techniques the non-traditional way. That is, without the use of predefined models or complex techniques, we were able to derive substantial mathematical equations using functions as cosine similarity, weighted averages, TF-IDF vectorizer, and k-means clustering. Second, for the same job, candidates could have widely ranging profiles. For example, people could be working as SG2 at the age of 24 as well as 37. This wide variety led us to implement sampling within the dataset to avoid extreme differences between the runs of the same candidate. So what's next for us? For future editions, we aim to take in a document which could be a candidate's own resume and process the same without needing for additional inputs from the candidates. This in turn would be a better suited environment for candidates to test out their tangible strengths before presenting the same to a recruiter. Now passing on to Ganesh so that we can deep dive through the project.
Hey guys, moving on to the next step. So here we have like 5 datasets that we got from Kaggle. So you can see some of the datasets are the applications that the candidates gave out, the user history of the candidates, the jobs that they are currently doing, and so on and so forth. So this is the data pre-processing part. This is where we do things like handling the missing values like null values, NA or zero values, whatever. And after that, we basically put it in a data frame to study what sort of data we are dealing with. So once we got the understanding of the same, we moved on to the modeling part. So as explained earlier, we basically built out 2 models. The first one is a job recommendation portal, which is basically letting people have like a recommendation of jobs based on their current profile. So as you can see here, what we did is we imported the job history of all these candidates that we had. And based on that history, what we did is we did a clever thing with TF-IDF where we just eliminated all sorts of other English grammar, you can say the repeated words, whatever that was not necessary, and we just picked up the keywords that were necessary. So once that was done, then we moved on to a simple cosine similarity algorithm, and we found out that this cosine similarity algorithm was able to better match these candidates to suitable job profiles than going for any traditional ML algorithms. So as you can see, this is just the part where we did the pre-processing. This is the TF-IDF vectorizer to eliminate the words that were unnecessary. And once we had the TF-IDF vectorizer matrix set, we just put it in a cosine similarity. And once the cosine similarity gets it, then we can see what sort of jobs you can have. So these are just some of the jobs that it could find based on the keyword that we are looking for. But when we pass in a real candidate, let me just scroll down to that part. So you can see here, So once we put in a real candidate, what it does is it matches it with what sort of candidates are having similar profiles to the candidate that we just listed out. And once we have the similar profiles, we can just go and look into what sort of similar profiles are available here. So you can see here that for this candidate who has probably some experience in the Air Force or the aircraft service domain, we got things like aircraft servicer, automotive service supervisor, so technician. So these are the kind of jobs that could be suitable for this specific candidate. Moving on to the profile scorer. So this is the second problem that we were trying to solve, in which case we just looked at what sort of tangible objective measures we could measure a candidate upon. So this is important as most of the candidates who are just putting out a resume have no clue as to where do they rank compared to the other candidates. So we just did a clever profile scoring algorithm here, which basically takes in things like graduation year, degree type, and the number of people they have managed previously. And based on that, we were able to create a simple, you can say, a class which basically figures out, okay, so based on these sorts of scores, this is how you compare to candidates who have worked in the similar profiles, and it gives out a matrix showcasing the candidates' current tangible accomplishments. So if I just scroll down to that part directly, so this is a part where we're just loading the data, getting it through the class that we just talked about, and you can see here. So once we pass on the candidate, we can see what sort of degree type he has, how it compares to the rest of the people in the industry. So here a negative score basically means people in a job in the same job profile or a similar job profile have better degrees compared to them. Same thing goes for total experience, currently employed or not, how many people they have managed before, and the current age that they are in, and what sort of profile score they have. So based on this, we are giving a it successful flag, which is basically representative of the candidate being able to secure that job because they are being considered to be in the top 10% of the candidates who applied for that. So, yep, that's all for today. I hope you had fun. Thank you.